Hello, this is Professor Means, and I am here giving you a tutorial on how to balance equations using the means method. And this was something I developed back in 1996. I remember as a student, I always dreaded doing balancing equation problems because I didn't really understand them all that well. It seemed very arbitrary, putting in numbers, and then you would have to change numbers. And I'm a person who likes rules and steps. I'm very methodical. So I knew when I first started teaching that I would have to come up with a way to better understand balancing equations so that I could explain it to my students. So back in 1996, I was sitting around one evening. It was probably a Friday night because, I'm cool like that, Friday night, and I'm thinking, hey, how can I teach students how to balance equations? So what I did is I got out some coins and I was like, okay, a quarter, you're going to represent carbon, nickel, you're going to be hydrogen, and so on. And then I would just manipulate the coins. And anyway, a pattern came up. And so every time I worked a different problem using these coins, I was able to balance every single time. So I thought, well, having students take out a bunch of change is not really feasible when teaching. So what I did is used colored squares. And so I taught it using color coding. And then that kind of developed into what it is today. And that's when we use shapes. So every time I've taught chemistry, I've taught balancing equations like this, and it's amazing because students have come back years later and they still remember how to balance equations using the means method. And I'm uh, really proud of it. I think it's a fun way to learn how to balance. And I'm all about making chemistry fun. So with the means method, you have my guarantee that as long as you follow my 4 rules, you will be able to balance any equation correctly the first time, no matter how large the coefficients are. And this is a beginning tutorial, so if you, some of the problems that we do will be pretty simplistic, and you could probably figure out the coefficients without actually using the means method, but I'm going to start with some easy ones to build up to some ones with more complex coefficients. So the means method consists of 4 rules, and it's important to follow those 4 rules. Otherwise, it will not work. So here are the 4 rules, and you may want to pause the video so that you can write down these 4 rules, and then we will get started. So basically, rule number 1 is we're going to make a shape for each element, and then it says horizontal. Number 2, make shapes equal on both sides of the arrow, and then we have the word vertical. And then number 3, I put a star by it because if a rule is overlooked, it's usually this one. It says, don't forget to feed the babies. Yes, you read that correctly. And number 4, count the rows to get coefficients. So let's take a look at one that is a good one to do to illustrate this. So we have iron, oxygen, and then iron and oxygen over here combined. And so we want to balance the equation. And when you balance, you can only add coefficients. You cannot add subscripts. So we have to, the whole goal of balancing equations is to get the elements on both sides, the reactants and the products. Here, let me help that, see if we can get that to focus there. We want the reactants and the products to be balanced on both sides. So if we have tin iron on this side, we want to have tin iron on that side. And we do that by adding coefficients. So using the means method, rule number 1 said that we're going to make a shape for each element. So I'm going to say, hey, iron, I'm going to represent you using a square. And then we bring our plus sign down. And oxygen, I'm going to represent with a circle. And we have 2 of them. So I'm going to go circle, circle. And on the first rule, it says make shapes for each element, and then it had in parentheses horizontal, and that's what I mean here, if you have 2 of something, we want to keep it going horizontal. And then we have an arrow, and then we have 2 irons. So we're going to go back over here. We chose a square for iron, and we have 2 of them. So square, square, and 3 oxygens, and we represented oxygen with a circle. And there are 3 of them. So 1, 2, 3. So now we can forget this top part up here and just focus on shapes. So now all we have to do is make the shapes equal on both sides. And we do that by using rule number 2, making the shapes equal on both sides of the arrow, and then it said vertical. So what that means is, over on this side I have 1 square, on this side I have 2 squares. So I need another square on this side. So I'm going to add it vertically. There we go. Now I have 2 squares, 2 squares. My squares are balanced. I have 2 circles, 3 circles. So I need a third circle over here. So I'm going to add one, which brings us into rule number 3, don't forget to feed the babies. So think of it this way. This is 1 baby, 2 babies, 5 babies. So if you're feeding a baby, you know if you feed one, you better feed the other one because they're going to be throwing a fit. So what I do to one, I must do to the other. So if I feed this one, then I must also feed this one. Okay? If there's a rule that's overlooked, it's that rule, forgetting to feed the babies. So now I have 2 squares, 4 circles. Over here I have 2 squares, 3 circles. So I need another circle, right? Because I need 4. So I'm going to add one. But these are all connected. These are 5 babies. So if I feed one, I must feed all of them. And you may be saying, well, but I don't need all of these other things. You just got to do it. That's the rule. So if I feed that one, I must feed all of these. All right. So it's a game. It's going back and forth. So now I have 1, 2 squares. I have 1, 2, 3, 4 squares. So I'm going to have to add 2 more, and I do that vertically. This baby is, you see, by itself, so there's nothing attached to it. And that's why it's important to bring these signs down, the pluses and the arrow, because if you don't, and if you're kind of sloppy, if these 2 things are too close together, it may look like you have 3 babies, when in fact you don't. So now I have 4 squares, 1, 2, 3, 4 squares. I have 4 circles, 2, 4, 6, 6 circles. So I need 2 more over here. Well, if I add 1 and feed the baby, I have my 6. So we have 2, 4, 4 squares. 1, 2, 3, 4. 4 squares on that side. 2, 4, 6 circles on this side, and 2, 4, 6 circles on that side. So my shapes are balanced on both sides. So rule number 4 said we're going to count the rows to get the coefficients. So right here I have 1, 2, 3, 4 rows. Right here I have 1, 2, 3 rows. And right here I have 1, 2 rows. If you follow all those rules, you have my guarantee that you will get these coefficients right the very first time. And then you can go back and just double check to prove my point. You have 4 irons. Over here you have 2 times 2, 4 irons. Here I have 3 times 2, 6 irons. And on this side, 2 times 3, 6 irons. So we are balanced. And that was kind of fun. Let's do another one. This time, let's do KClO3. This is going to be a decomposition reaction, so we're going to break this down. Let me put my little arrows there. And then That's going to break into oxygen and KCl. All right. Let me bring this in focus. There we go. So let's say we want to use, that's out of focus again. There we go. Let's use a square for K. So I have one K. And let's say a star for Cl, and I have one Cl. And I have 3 oxygens, so I like to keep my circles. I'm going to draw in my arrow. And on this side, 2 oxygens, so 1, 2 circles. Bring down my plus sign. And I have a K, which was a square, and a Cl, which was a star. And if for some reason you're working these down and it just seems to keep going on and on and on, you may want to go back and make sure that you did write the equation correctly if you're working one out of your book. So you can start with any element. I'm going to start with the square. 1 square, 1 square. 1 star, 1 star. And then we have 3 circles and 2 circles. So I need a 3rd circle. And I need to feed the babies because I have 2 here. So what I do to one, I have to do to the other. Now I have 1, 2, 3, 4 circles, and over here 3 circles. So I need a 4th. But what do we have here? We have 5 babies. They're all stuck together. So what I do to one, I have to do to the rest. I have to feed all of these guys here. So now I have 1, 2 squares. Over here I just have 1 square. So I need to add another square and feed my baby. 2 squares, 2 squares, 2 stars, 2 stars, 2, 4, 6 circles, 2, 4. So I need a 5th and a 6th circle. And now everything should be balanced. 2 squares, 2 squares, 2 stars, 2 stars, 6 circles, 6 circles. So to get our coefficients, we just count the rows. 1, 2, 1, 2, 3, 1, 2. So our coefficient's 2, 3, 2. And again, you can double check the math up here. 2 potassiums, 2 potassiums, 2 chlorines, 2 chlorines. 2 times 3 is 6, 6 oxygens, and 3 times 2 is 6, 6 oxygens here. All right. Let's do another one. That's a little, we're going to just increase the complexity a little bit. On this one, we're going to have B4O7 plus H2O. And then we're going to have H3BO3 plus OH. Okay. Let's see, focus, focus. Okay. So for B, let's say B is a star, and I have 4 of them. There we go. And then we have 7 oxygens. So we're going to have 7 circles. This is all one thing, so it's a long strand of babies. And I'm just going to crunch these in there. 1, 2, 3, 4, 5, 6, 7. Plus H, let's say that's a square, and I have 2 of them, and a circle for oxygen. Over here I have 3 hydrogens, and hydrogens were a square, so 1, 2, 3. Boron was a star, so 1 star, 3 circles, plus circle, square. Okay. Again, make sure you bring down the plus signs and bring down your arrows so that you don't merge these babies together. Okay, so again, you can take any shape. The stars jump out at me because I have 4 stars here and 1 star here. So I need 3 more stars. Oh my gosh, what do I have here? Like 7 babies. So I have to feed all of these guys. Okay. So 4 stars, 4 stars. Let's take a look next at squares. Right here I have 2 squares on this side of the arrow. Over on this side of the arrow, I have 3, 3, 3, 3. That's 12. And don't forget this one. That's also, if a mistake is made, it's forgetting to total up the collective number of shapes on both sides. So I have 12 squares plus this one will give us 13. And it will never balance if you forget that there's an extra square over there. So I have 13 squares on the right side. So I need 13 squares on this side. So if I add and feed at the same time, there's 4, 6, 8, 10, 12, 13, but I've got to feed, so that's going to take me to 14. And then don't forget, we have 3 babies here, not just 2. So I've got to go down and add my circles. So 2, 4, 6, 8, 10, 12, 14 squares on this side. And we said there were 13 squares over on this side. So it makes more sense if I have an odd number on this side to add my square here to make it an even number rather than adding it over here. So let's add over here to make that 14 squares on this side. And this is a baby, so I've got to connect. So let's see what we have. Let's do it total, and maybe our oxygens are gonna, or our circles are gonna come out even. 4 stars, 4 stars, 2, 4, 6, 8, 10, 12, 14 squares on this side, 3, 3, 3, 3, that's 12, 13, 14 squares on that side. So we're gonna now add our circles, and remember the collective number of circles on both sides. So here I had 7, 8, 9, 10, 11, 12, 13, 14 total circles on this side. And over here I have 3, 3, 3, 3. That's 12, 13, 14. So 14 circles on that side. So this is balanced. So I'm ready for my coefficients. So here I have 1 row. Here I have 1, 2, 3, 4, 5, 6, 7. Here I have 1, 2, 3, 4. And here 1, 2. Okay, and then you can go and double check up here. And remember, you have my guarantee if we followed all those rules and we wrote our original problem here correctly, these coefficients will be correct. Okay, let's look at one that has some parentheses involved. And this is something that I tell my students. This may seem a little, I'll come in here. It may seem a little awkward at first, just dealing with shapes. But if you continue working through them and practice and use those rules, I've never had a student who could not balance equations. Let's put it that way. Okay, let's look at our next one. And for this one, this is going to be kind of a long one. So we're going to start over here. Magnesium 3N2 plus H2SO4. We're going to have magnesium sulfate plus okay, so on this one we have lots of elements actually to choose from. And remember, even though we have polyatomic ions, whenever you're balancing using the means method, we don't look at those as polyatomic ions. We break everything down into individual elements. So let's say magnesium is represented by a triangle, and I have 3 of them. And let's say that nitrogen is a star, and I have 2 of those. And then we have hydrogen. Let's make that a square. Sulfur, let's make that a heart. And then 1, 2, 3, 4 circles for oxygen. And then we have magnesium, which was a triangle. Sulfur, which was a heart. Oxygen, 2, 3, 4. Okay, and I'm going to scrunch these in. So here we have some parentheses. So don't forget the subscript that's on the outside of the parentheses means that we have, in this case, a 2 means we have 2 of these NH4s. So we have 2 nitrogens, and we said nitrogen was a star, so star, star. And we have 2 times 4, 8 hydrogens. And we said hydrogens were square, so I'm going to squeeze those in here. And then I have a sulfur, which is a heart, and 4 circles. So if in this one, if by chance we have to add another star here, we've got to feed all of these babies. But we'll see if we have to do that. So again, you can choose any shape to start off with. I like to start off with the ones that just kind of jump out at me, like I have 3 triangles here and 1 triangle there. Oh, and by the way, do you see how if you forgot to bring that plus sign down, then this may look like it's all together? Again, so bring down the plus sign. So 3 triangles here, 1 triangle there. So I need 2 more. So 1, 2. I have, what, 6 babies here? So I've got to feed all of them. So now I have 3 triangles, 3 triangles. I have 2 stars, 2 stars. I have 1 heart, 3 hearts. So let's add 2 more hearts. And I've got to feed, so I've got to add my squares and my circles. So 3 triangles, 3 triangles. 2 stars, 2 stars. 1, 2, 3 hearts on this side. 1, 2, 3, 4 hearts on that side. See, I almost forgot that there was a heart over there. So we need a 4th heart over here, right? Because we have 3 and then that one that I almost forgot about. So we need to add a 4th heart. And then feed these babies. So now let's see, 3 triangles, 3 triangles, 2 stars, 2 stars, 4 total hearts on the left, 1, 2, 3, 4 total hearts on the right. Let's do our squares next. 2, 4, 6, 8. And over here I have 2, 4, 6, 8. On my circles, I have 4, 4, 4, and 4, so that's 16. And over here I have 4, 4, 4, so there's 12. 13, 14, 15, 16 on that side. So we are balanced. To get my coefficients, I'm going to add my rows. So that's 1 row, 1, 2, 3, 4, 1, 2, 3, and 1. And I forgot to put in a little line there. Now, you probably already know that technically the ones are understood, so if you are seeing this in a book or anything, it will just say Mg3N2 plus 4 H2SO4. They're not going to have the ones in there. But for teaching purposes, I like to include the ones. Okay, let's do one where I'll set it up and then we'll let you work it and then we'll check it. So on this one, let's do aluminum plus HCl, and that's going to yield aluminum chloride plus or hydrogen. And on this one, let's do this. Let's say that Al there we go. Al is going to be a triangle. H, let's make that a square. And Cl, let's make that a circle. So what you can do is, if you would like to pause here and then work this out, and then you can push play again, and we'll work it out up here. So my Al is going to be a triangle plus square circle. Okay, so that's how it should look. My triangles are equal on both sides. I have a square, one square on this side, 2 on that side, so I'm going to add another square. And I've got to feed that baby. So 1 triangle, 2 squares, 3 circles, 2 circles. So I need to add another circle, which means I have to add another square. So now my triangles are balanced, my circles are balanced, but my squares are no longer balanced. So I have 3 on this side and 2 on that side. So if I add a third and feed, I have 4. 4 squares on that side, 3 squares on this side, so I need to add 1 more square and in turn feed that baby. Okay, our triangles are okay, our squares are okay, but now our circles are not. I have 4 circles, 3 circles. So we have to add 1, but then we got to feed all these guys. So we'll feed them. Oh, that made you have 2 triangles, so we got to add a second triangle over here. So see, this is kind of fun, right? Because it's like a game. So we have 6 circles here and 4 circles there. So we need 2 more circles. And we've got to feed. So let's see what we have now. 2 triangles, 2 triangles. 1, 2, 3, 4, 5, 6 squares, 4 squares. We need to add and feed. And now we have 6 squares on this side and 6 squares on this side. 6 circles on this side and 6 circles on this side. So we are now balanced. So did you get coefficients 2, 1, 2, 3, 4, 5, 6, 1, 2, 1, 2, 3? Let's see, so did you get coefficients 2, 6, 2, 3? If you did, congratulations. You have learned how to do the means method, and I hope you have enjoyed that. Yeah, I think it makes balancing so much more fun. I actually enjoy balancing equations now. Um, and so, as always, make chemistry fun. Until next time, this is Professor Means.